Lesson 67, Finding Inverse Trigonometric Functions. Evaluation of trigonometric functions for given angle measures was explained in Lesson 46. Angle measures that have a given trigonometric function value can be found using inverse trigonometric relations. So they say that if a function value is sine of theta, this is our angle measure, is equal to A, then we could find our angle measure by using the inverse sine, which is a function on your calculator, and that A to find your angle measure. Okay? And the same thing is true for cosine and tangent. You should write this information in your notes. It says the inverses of trigonometric functions are not functions themselves because there are many values for theta for a particular value of A. For example, consider that inverse cosine of radical 2 over 2. Angles with measures of 4 or pi over 4 and 7 pi over 4 radians have the cosine value of radical 2 over 2. So do all angles that are coterminal with these angles. So remember that our cosine is our x value and our sine is our y value. And what they're saying is that at this point, which is at pi over 4, we could get this radical 2 over 2 for our inverse cosine, and the same is true for 7 over pi, and that gives us that same radical 2 over 2. Okay, they're saying that so do all angles that are coterminal. If you went around the full time, if you went from here one full circle all the way around and then you stopped at that point, well, then you would know that it's the exact same thing again. So, okay, this says to describe all of the values of inverse sine of radical 3 over 2. So I went ahead and I gave you the unit circle because you're going to need, oh, is that negative or just, no, it's not negative. Because you're going to need to be able to use the unit circle to help you solve these. So, remember we said it goes cosine and then sine for our order of operations. So we're looking for y values that are radical 3 over 2. So as I'm looking at my y values, this is x and then y, so I have 0, 1/2, radical 2 over 2. Here's one where I have radical 3 over 2, and that is for this pi over 3, or 60 degrees. So that's one, and let's continue on. We have another one here at 2 pi over 3, and as we continue around, these are negatives, so those don't work. So, oops, I didn't do that. So my angle measures that inverse sine is radical 3 over 2 is going to be pi over 3 and 2 pi over 3. Okay? So all you have to do is refer to your unit circle to help you figure these out. It says to define inverse trigonometric functions, it is necessary to restrict the domains of trigonometric functions. The trigonometric functions that a calculator uses have restricted domains and will only give one value in the range that you will need to generalize to find all possible values. So sine for theta, it says ranges between negative pi over 2 and pi over 2. Okay? So it says theta can terminate on the y-axis, the positive x-axis, or in quadrant 1 or 4. So negative pi over 2 is here. Okay, pi over 2 is here. It's ranging in this area. So this is where sine is. Okay. This one ranges from 0 to pi. 0, we all know, starts here. And if this is half a pi, then this has to be a full pi. So this is for cosine, this part here, which is quadrants 1 and 2. Okay. And finally, for tangent, we have negative pi over 2 to pi over 2, which is again these quadrants. Okay. Sine, cosine, and tangent can be used to define the inverse trigonometric functions. For each value of a in the domain of any inverse function, there is only one there is one and only one value of theta in the range. Okay, so this gives it to you the exact same thing essentially. So the inverse sine function, I have inverse sine of a, that is -1 to 1. They give us that negative pi over 2 to pi over 2, or negative 90 degrees to 90 degrees. You can write this information in your notes. Okay, so it says find each inverse trig function, find each inverse trigonometric function value that exists. Give answer in both radians and degrees. So this one, I'm talking about tangent. Remember for tangent that we're only looking at quadrants 1 and 4, so it has to be something over here. So I don't have anything the same here, no. These are the same, but they're both positive, so that could be a positive. Doesn't work, doesn't work. So if we go here, not the same. These are the same, but I have a positive and a negative. Okay, so we're talking about 7 pi over 4, which we could also call, we could say that tangent, or inverse tangent, excuse me, of -1 is equal to negative pi over 4, because 8 pi over 4 would be here, right, 2 pi, and I'm going down pi over 4, so that's negative, and the other would be the degree measure, which is, this says 315, which I take from 360 to get 45 degrees. It wants me to find cosine, or inverse cosine of 2, and from that chart 2 slides ago, you saw that that went from -1 to 1. So what this tells us, I don't have to, this is undefined. Okay, because it doesn't go up to 2, it doesn't work, so undefined. Okay, on this one, it wants us to solve 2 cosine theta equals radical 3 for 0 degrees to 360 degrees. We're using this whole thing, and we're solving for theta, okay? So I'm going to rewrite 2 cosine theta equals, radical 3. Well, to get cosine of theta by itself, we're going to divide by 2 on both sides. Okay, so now I have cosine of theta equals radical 3 over 2. Alright, and then all I have to do is find where cosine is radical 3 over 2. Remember, we go cosine sine, so it is our x value. We're looking for 3 over 2. So here I have 3 over 2, and it wants degrees, okay, so I don't care about this radian measure, but I do want the 30 degrees. And then if I continue on, see, I'm looking, this one is a negative. I don't want negative, I want positive. So I continue, that one's also negative, and my last positive one is right here, and that degree measure is there. So the answer for this one would be theta equals 30 degrees or 330 degrees. Same thing here, we're looking for the degree measure. So I have 5 sine theta equals 5. To get it by itself, I'm going to divide by 5 on both sides. So I have that sine of theta is equal to 5 over 5, which is 1. Again, we have cosine sine, which means I'm looking for a y value equal to 1. So the only place that I have a y value equal to 1 is right here, and that's at 90 degrees. So theta equals 90 degrees. Okay, same thing here. I have 6 sine theta plus 3 equals 0. I'm solving for theta, so I'm going to subtract 3 from both sides. I have 6 sine theta equals -3. Divide by 6 on both sides. So I have sine of theta equals -3 over 6 is a -1/2. So again, I have cosine sine. So I'm looking for a y value equal to -1/2. Okay, so that's a positive 1/2. That's a positive 1/2. Here's a -1/2. And here's a negative 1/2. And where theta is any real number of radians, so the radian measures are at 7 pi over 6 and at 11 pi over 6. Okay. On these, I know that you'll be happy because we're going to use your calculator to solve these. We're going to start them the same way though. So I'm going to rewrite 10 cosine of theta equals 6. I want to get this by itself, so I'm going to divide by 10 on both sides, which gives me that cosine of theta equals 0.6. Okay, to get theta by itself here, I'm going to multiply by inverse cosine on both sides. Okay, so cosines over here will cancel each other out, leaving me with theta is equal to inverse cosine of 0.6. And when I punch that into my calculator, you just hit second cosine and it'll bring up your inverse cosine, 0.6, and it gives me, oops, I'm in the wrong mode. You have to make sure that you are in degree mode for this because it just gave me radians. And to change your mode, you just go to mode and then go down to radian and over to degree and hit enter, so that degree is what's highlighted. So what I have is that theta is approximately, we'll round it to 1 decimal place, we'll say 53.1 degrees. Same thing here. I'm going to get that theta by itself, so I have, oh wait a second, this is the exact same one, right? Yes. Okay, and this was from 0 to 180 degrees. The other one says that it's from 270 to 360 degrees. So first of all, I already know that this theta on the last one was about 53.1 degrees. So because I want it to be between 270 degrees and 360 degrees, all I have to do is take 360 degrees and subtract this 53.1 degrees. And when I do that, I get 306.9 degrees. Final answer. Last example says a pair of hikers plan to walk from a campground to a waterfall. The waterfall is 2.5 miles east and 1.5 miles north of the campground. To the nearest degree, in what direction should the hikers head? So they're wanting to get the shortest distance. They don't want to have to walk all the way 2.5 miles east and then 0.5 miles north. So what we're going to do is we're going to draw a picture. So the campground, they are camping out in tents. Okay. So this is their tent, and from their campground it says they're going 2.5 miles east, which we just talked about the other day. Whenever we show direction, east is going to be to the right. So I'm going to show 2.5 miles east. Okay, and then from this point it says a half a mile north. So I'm going to go up a half a mile because north we said would be up, and we're trying to get to the waterfall. Okay. They don't want to walk 2.5 and then another half mile, so 3 miles. They want to take the shortest distance, but they don't know what angle that they should walk at from their campsite. I know that this distance was 2.5. I know that this distance was 0.5. So I want to know what theta is. I want to know that angle measure. Well, I've been given the opposite and adjacent, right? Opposite and adjacent. So I know that that is tangent is equal to opposite over adjacent. Alright, so then all I have to do is plug this in, or tangent of theta. Okay, so I have tangent of theta is equal to the opposite, which is 0.5, over the adjacent, which is 2.5. So I'm going to punch that part into my calculator. I have tangent of theta equals 0.5 divided by 2.5. That gives me a 0.2. And I'm going to solve this the same way I did on the last one. I'm going to multiply by that inverse tangent on both sides. So I have those. Theta is then equal to inverse tangent of 0.2, which I can punch into my calculator. Second tangent gives me inverse tangent. Plug in 0.2. And it tells me that it's approximately 11 0.3 degrees or just 11 degrees. And that is all I have for you. This is your homework assignment. It will be due on Monday, along with your lesson 66. This and lesson 66 are due on Monday. You can find this on my YouTube channel at Mrs. Dotson Loves Math. If you need to view it again while you're working on your homework, I hope that you have a good weekend.